All right, thanks, Tim. Thanks, everybody, for coming this morning to the talk on making sense of schema on read. My name is Kent Graziano. I am the Chief Technical Evangelist with Snowflake Computing. And I have to fix my clicker here and get in the right window. There we go. So I've been in the community here for nearly 30 years. Tim and I met back in Denver years ago at the Rocky Mountain Oracle User Group. I am an ACE Director alumni in the data warehouse and BI field. I'm a member of Oaktable, have a blog. I've been doing this data stuff for a very, very long time. I've been involved with the user groups, Oaktable, everything also for a very long time. The company I work for is called Snowflake Computing. We are a privately held startup based here in Silicon Valley down in San Mateo. Spent 3 years in stealth and have been GA for 3 years now. We were founded in 2012 actually by two gentlemen from Oracle who worked on the optimizer engine and the parallel execution engine and a bunch of other really cool things that we all rely on in the Oracle world. They had over 120 database patents between them when they founded Snowflake and have filed another 27 since it's been founded. I forgot to get this slide updated. It says we have over 400 million in venture funding, but as of 2 weeks ago, that jumped to 850 million because we had another round of funding for $450 million and are now valued at 3.5 billion. First customers started using Snowflake back in 2014 and became available in 2015, and we now have, it says 600 plus. I checked with HR yesterday and we've now broken the 700 barrier. I started 3 years ago when there was 100 employees, and we're now up to 700 on 3 continents. Some fun facts about Snowflake. Queries processed in Snowflake per day is 60 million, and it's all analytic processing. We are a cloud-based data warehouse system. The single largest fact table that somebody stored in Snowflake is 68 trillion rows. So it scales fairly well. The largest number of tables in a single database, 200,000. Now, I was at a data modeling conference last week and we had some debate over maybe these people need a little bit of data governance. The fact that they've got 200,000 tables in a single database is maybe a little questionable, but it's really cool that they can do it. I think that's kind of a neat number there. The largest single customer has over 40 petabytes of data stored in Snowflake and has over 10,000 users. And the largest number we've seen to date is somebody actually having 3,000 concurrent queries running at one time in their Snowflake system. So if you want to learn more about Snowflake, you can talk to myself, Michael, or Danny during the breaks later on. There's some fancy Snowflake stickers, because everybody loves stickers, out on one of the tables out in the lobby. Feel free to pick one of those up. So what are we going to talk about? Schema on read versus schema on write. Probably old hat for some of you, but gives me an opportunity to rant a little bit, which I love doing. Why we still need data modeling. My favorite discussion of all time. A little bit of what is JSON actually, for those who don't know. And then I've got 2 examples, a fairly trivial example of a JSON document and a slightly more complex example. And what I'm going to do is walk through turning those into a data model, a third normal form data model, and a data vault style data warehouse model. So we're going to walk through these documents and see what it looks like when we try to convert them into something that most of us would recognize because we do database design. So terms, schema on read. So this is something they started talking about with big data and NoSQL databases, is having schema on read. Isn't this a wonderful thing? We no longer have to do upfront modeling. We could just load our data into a database and walk away, right? And we can change it at the drop of a hat. Change the input form, save the new data, never having to touch your database again. No predefined structures. That was the benefit of this concept of schema on read. A lot of people started calling it unstructured data back when Hadoop and everything first came out, but in reality, it's a semi-structured data. There is structure, as you're going to see, to these type of documents. Claudia Imhoff tends to call them flexible structured data elements because the structure can change, which is another one of the benefits of schema on read technology, is that the schema can change over time without breaking what you've already built. The idea, load your data and go. And that is, we'll say, quote unquote, agile. And that's what everybody wants, right? How fast can we get going? Well, if we can get rid of all those stinking data modelers who take years to talk to the business people and develop these entity relationship models, and we wait and we wait and wait, and then we finally get to build a database and we put data in it and it breaks because we forgot 5 things. So the benefit in theory of schema on read is that you don't have to do any of that. On the other side is the schema on write, which is what all of us are familiar with that have been in the field for years. This is what we do in our relational databases today. We do some analysis, we create a model, we create a design, depending on what you call it, whether it's a logical model or a physical model or a schema design, all kinds of different terms for this, but we basically come up with tables and columns and constraints. And then we put it into a database, and then we start loading the data. In the data warehousing world, which is where I tend to work most of the time, if you're doing ETL or ELT, extract load transform, when things change in your source systems, your data warehouse structures don't break, but your data pipeline breaks. Has anybody ever had a data warehouse pipeline that one night your ETL process fails because somebody changed the source system and didn't tell you? Yeah. So that's the downside of schema on write, is you have to know that the structure changed so you can change the database. With all the data that's coming around today, we have to find ways to deal with this, I'll say, more efficiently. And to me, it's going to be some sort of a hybrid. The predictions now are 40 zettabytes of data by 2020, coming from all over the place, from mobile apps, enterprise applications, the traditional ERP things, but now, of course, IoT. That's generating all kinds of logs, which tend to be in this form, most often JSON, though sometimes some other semi-structured formats as well. And the problem's not so much all the volume of data. I think we've beat that. Hadoop helped us beat the issue about big data. Where do we store all this data? How can we store it cheaply? That problem's been solved. The bigger problem now is, yeah, now we got all that data, what are we going to do with it? So that's where we have to talk about, how do we model these things? What are we doing with a schema on read? When the big data era hit, and even today, I talk to customers that still ask this question, do we need to do data modeling? Are you building a data warehouse? Yes, you still need to do data modeling, right? If you're going to take advantage of all this data we've stored, we have to be able to use it. We have to be able to express it in a form that is understandable to mere mortals. Or in the data warehouse world, to BI tools. Right? The BI tools can't just look at a blob of data and suddenly turn it into analytics. Somebody has to do something with it. Even with schema on read, the word schema is in the phrase. A schema is a model, right? So the challenge is getting that model out of this flexible structured data, this semi-structured data, and understanding it. In order for end users to use it, we have to be able to express that model in a particular form that allows them to see what's there and see the semantics of the data in order to query it and make use of it. Most BI tools can't do that automatically. So you have to somehow transform those structures into something understandable by BI tools. And that's, whether you're talking business objects, Oracle BI, cloud-based tools like Looker, and all the new tools that are out there, it still has to show up looking like a table to those tools. And that may mean just putting a view on top of it. So what is JSON specifically? It's JavaScript object notation. So if you didn't know what JSON stood for, that's what it actually stands for. It was designed originally to be this is one of the official definitions, a minimally readable format for structuring data. So this idea that it's unstructured data doesn't even hold up when you start looking at the basic definition of what is JSON. It's a way of structuring data. Originally, it was used and thought of as a alternative to XML. And we all have been looking at that for 20 years. You can look at an XML document and you can tell what the data is in there. There's structure. That's the same thing is true for JSON. So the worry about JSON, though, is there's a lot more of it out there now. Modern applications are generating JSON like crazy. JavaScript has become very popular. I mean, JDeveloper, right? How long have we had JDeveloper now in the Oracle world? We're dealing with Java, and then people are doing JavaScript in the web. REST APIs and IoT and mobile devices are all expressing data and storing data in JSON format. Application weblogs, social media. If you get the Twitter API, guess what it comes in? JSON. It's all coming in JSON, people. That's what we got to do. We got to figure this out. It is self-describing, so you don't have to have another document to tell you what the structure is, but you do have to be able to read the structure. And that's what it means by self-describing, and I'll show you examples in a minute. There are a lot of open data sets published in JSON, so if you are doing analytics and BI and data warehousing, there's data out there that you can add to the mix of what you're doing analysis on that are published by organizations and is published in JSON. So data.gov, datasf.org, datacityofnewyork.us. New York City publishes a whole bunch of data that I know I've seen people grab and throw into Apex and throw into all kinds of different applications to augment their analysis and actually make their analysis better. On the technology side, we now have platforms, Oracle, Snowflake, MySQL, several others that have the ability to take this semi-structured data and express it in a relational way and allow you to join that data to structured data. And so this is how we're going to augment that analysis, be able to take a Twitter feed and pull attributes out of that JSON and join it to, say, a product dimension to augment your analysis. So here, ready to go. JSON example number 1. This is a JSON document. It is bound by curly brackets at the top and the bottom. It is a key value pair style structure. You have a key, in this case color, a colon, and then the value, and everything's in quotes. Each of these elements may have nested keys. And again, you got more curly brackets to do that. So in this case, you have code, and code is defined by 2 additional keys, RGBA and hex, each of which have values. And then some of the values may themselves be arrays, and those arrays are bound by square brackets, right? So we've got keys, values, nested keys, and arrays within keys. So now, how do we transform this into a model? First, we're going to look at third normal form, logical model, and I am using SQL Developer Data Modeler to do this. No magic there. All right, so the very first one, entity color. The hashtag there in the diagram, in this case, is not what we now use in social media. It actually represents a unique identifier when you're using Oracle Data Modeler. The little red star means it's mandatory. So I've got an entity, color, and the unique identifier is color name. Now, for those of you who are like really experienced data modelers, somewhere in this talk you will find something that you disagree with that I did. Get over it. This is an example. Everybody knows there's a lot of different ways to model things, so I'll just say that up front, especially dealing with yoke table. Yeah, let's not get really hung up on, yeah, is this the exact perfect model for this document? Maybe, probably not. We'll just be honest, probably not. So don't get too hung up on that. Just stay with me. You know, this is the willing suspension of belief, right? Just consider this is the real model. All right, then we have two other keys down here, category and type. Well, to me, those sounds like lookup tables, right? Lookup entities, reference entities. So I've got two more entities here, color category, color type, each of which has a unique identifier, category code, and type code. And you notice I expanded a little bit beyond the tag, the key that's in the JSON document. So I'm trying to think from a business perspective. If I just say category, yeah, it's not overly descriptive. This is a code in this case. Type, same thing, it's a code. So I'm making it a little more verbose in what I do with my model. And then down here we have the color code defined by the hex address. And as it turns out, I had to do a little research. RGBA is red, green, blue, and alpha. So there's values for all of those. So this is what it looks like in Oracle Data Modeler. You have a logical model, which is true entity relationship modeling. That are just relationships, entities, things have lookups, but they're not cascading the keys over into like a table structure. But then you convert it to a schema model. So you're going to go through the same thing and say, what does this look like as a schema model? Well, we have a colors table. And because of all those foreign keys and relationships that I showed in the logical model, it's inheriting the keys from those associated entities. So we have category code, type code, and hex have been all inherited over into your color model, your color table. And then you have the lookup tables, which, again, this is a very simple document. It doesn't have a lot of things there. Arguably, you would hope there's descriptions and things like that in a real model, but the data we have doesn't have that, so I didn't model it, right? Doing agile modeling now, I'm modeling what I have and trying not to extrapolate too much. So this is a schema diagram in Data Modeler. Notice the color is a little different. They're square boxes rather than rounded corners. And now you see data types. So I had to guess data types. Well, how would you do that normally? You have to profile the data. So I had to do the same thing. You gotta look at the JSON document, profile the data, take a wild guess on how long an element. Again, we're dealing flexible schema structures here that, well, it could change, so don't box yourself in too much if you can avoid it, unless you've got a data dictionary somewhere telling you what is in this JSON document. So I put in integers and put in bar chars, define primary keys. So you see P there as primary key versus the hashtag in the logical model, which meant unique identifier. So there's a little difference between the actual table specification versus the business logical model that I built. And then I have one more lookup here is the color type. And again, it's type code, and you see the primary keys there. So nice thing about Oracle Data Modeler, it has a lot of options on display. I have most everything turned on. You know, if you don't want to show, if you see under the line there, you have the primary key definition, and additionally, then you've got the foreign key definitions. You can choose to show those or not show those on your diagram, but regardless, I wanted to put it there so it shows you that the modeler is actually creating all of these constraints. When you go to generate DDL, you'll get a create constraint statement. All of it's going to actually be there. As I said, you can model things a lot of different ways. One of the things you could do if you're doing reporting is you could denormalize that relational model. So in the first one here, we have 4 tables, and all I did was just roll them all together. And this basically looks like my JSON document. So if you're going to do reporting, you may choose to denormalize it. It's not wrong, just depends on what you're trying to do. So in this case, I just have a color table and everything's in it. Color name, category, type, the RGBA code I rolled together into a varchar because that's the way it looks in the JSON document, and the hex code, and just put it all in there. Gave it a primary key for the color name and a unique key constraint also on color name. And that's it, real easy. All right, so Data Vault. For those of you who don't know what Data Vault is an agile engineering technique for data warehousing specifically. It's designed, well, it was developed to design in an agile manner a fine-grained foundational data warehouse model that's going to store everything over time, right? It's a hybrid between third normal form and star schema. So this is not a star schema design, this is a data vault design. And I happen to be an expert at that, so I like expressing things in those terms too. So now we're gonna look at the same document, but from a data vault perspective. Data vaults start with hubs. Hubs are business keys. The key, the whole key, and nothing but the key. Thank you. I can always count, at least one person in the audience will say, so help me God. Yes, so that's 6 normal form. So this is a very low level modeling technique. So in the case of what we're doing here with this JSON document, I started off with the code category. The primary business key there is category code, which happens to be the word primary in this case. Then we have another hub for the color type, and another hub for the color code. And then there's this thing called a satellite. So in Data Vault, attributes that are dependent on the key but are not part of the key roll off into a child table. This is basically third normal form. And because this is a data warehouse modeling technique, we also throw load date in there so we can capture changes over time. So if those attributes that are dependent on the key change over time, we load a new record into a satellite, similar to a type 2 slowly changing dimension. So I've added that in. And then how we tie it all together is with the thing called a link table, which is effectively an associative entity. So in this case, I'm saying that our color definition is the combination of the keys from the color code, the color category, and the color type. That if you combine those 3 things together, you get a unique definition of a color. So this is a data vault style model. As you can see, there's a lot more attributes. It's a lot more complex, but it's also broken down to a very fine level of granularity that I'll explain here in a bit of the different things that we can do with it. Now there are some additional information hanging off of color that is dependent on color. In this case, I put it into the satellite hanging off of the link. Both satellites are third normal form. They're attributes that are completely dependent on the key expressed in the parent. So hubs and links are 6 normal forms, satellites are third normal form. So schema on read, one of the benefits of it in theory is that we can handle changes to that document easily. If you're doing a NoSQL database, you don't have to do anything, you just load the data, as I said before. Well, so now we've tried to model that so that we can report on it. How are we going to deal with this? In some of the database technologies out there, NoSQL, Snowflake, and Oracle specifically that I know of, if the document changes, there's no impact to your database. The new document just loads into the column and everything's cool. Downstream, if you've built views on top of it, it won't break. That's all cool. So things that could possibly change is, if you remember, if we look back at color category and color type, it was just a value. There's no description. So imagine somebody puts a detailed description in, adds more metadata into the document. In a third normal form model, you would basically add new columns, right? And you would have to do an alter table. And this is where the arguments on schema on read versus schema on write come in. In a data vault model, most often we would add a new satellite. If it's something related to an existing hub, a business key, we would add a new table. So we're going to not do an alter table, we're just going to do a create table. And that's part of the data vault agile methodology, is it keeps us from having to refactor things that we've already built. All right, example number 2. This is a little more complicated. As you can see, had to put it into 2 columns so I could get it all on one page. And it's, well, it's really small print for me, but it looks pretty good for you guys. Unless you're sitting like way in the back. So now, in addition to what I had in the prior document, we now have some more nested elements. So in this case, we got phone number is made up of an area code and a subscriber number. And now this is the fun part. We have a nested array of elements underneath. So children is an element, but within children now we have an array of elements where we've got name, gender, age, name, gender, age, name, gender, age. So we've got 3 nested elements in there. And then the really fun one is a nested array of values within a nested array of elements. So in this case, it's years lived. So we have the nested array of cities lived with city name and years lived 3 times, just like we have with the children. But years lived itself is an array of the number of the specific years that an individual, in this case Johnny Appleseed, lived in these various cities. So this makes the modeling a little more challenging and a little more real world. So third normal form approach, we have an entity called person, because there's actually no name in the document really, right? There's no object name. So I made one up. I was like, what is that? Oh, that's a person. Johnny Appleseed, age 42, gender male, right? So this is a third normal form model. And we're going to pretend like name is actually unique. I know that's not right. So this is one of those things, willing suspension of belief for a little period of time here. And a couple attributes dependent on the name. And then we have the phone number, which is a one-to-many relationship. Each individual could have more than one phone. And within that phone number in the JSON document, we had 2 nested elements, area code and subscriber number. And so I've said that's the unique identifier. Those 2 elements together make the business key for a phone number in combination with the name, because it is a dependency. Interesting, fun part here is the nested array of elements is actually just a recursive relationship, because children are people too. In most households. Well, yeah, I know. I knew I would get some arguments about that with this group, yes. But yes, I know. You may not believe it now, depending on what age your children are, but children are people, right? And they have the same characteristics that we do. They have names, they have ages, and they have genders. Then we've got city. So this is another entity with a name. So that's city with city name. And then we have city lived. Well, that's an associative entity. Somebody, each person may have lived in one or more cities. And each city maybe has been lived in by one or more people. That's an associative entity. It's actually a many-to-many relationship. But that's what we have. And then we have in here years lived, and that's an array too, right? You could have lived in the same city multiple times in the past or present or perhaps even future. So the key for city lived is inherited. The little tick mark you see below the crow's feet coming from city and person indicate that the unique identifier from those parents, person and city, are inherited and are part of the key for city lived. So the key there is going to be person, city name, and year. That's your unique identifier. This translates fairly easily into a table design. Right? So we have person, name, age, gender, and the recursive relationship turns into a foreign key and another element called parent name, which is an optional attribute. Right? Because somewhere there's a top of the hierarchy. Right? And even if you're doing genealogy, it eventually stops at Adam. Unless you want to put God in as a person, but you know that we're starting to get into some metaphysical conversations that are better done over beer later this afternoon. So city lived, you can see now the inherited keys, and this is the way data modeler deals with it. As I said before, you've got the logical model, which was the diagram before, which is all in blue with rounded corners, and you don't have nearly as many objects showing up. Those are attributes in this case. They're called attributes. When you go to the physical model or the schema design, they're called tables and columns. So a little terminology. So we've now inherited up there in city lived, name, city name, and year, and all three of those define the primary key. So in this case, city lived is actually 6 normal form. It's all key based on the document definition we started working with. So now, how do we handle schema changes? Well, imagine your kids get a phone. Well, you probably don't have to imagine that. Since we did define children as persons, and phone is a person phone really, well, then you can just add the data in and you're good, right? This model will handle that. No change at all. So they change the JSON document and start sending you phone numbers for children. No problem. You don't have to change your data model. Your kids move out. We can all hope, right? Someday, before they're 30, that they move out, right? You know, some of us can't wait for that day to come. Yep. And well, that handles it here too, because cities lived is associated with person, and as we established previously, yes, the children are people. So the model does not have to change, even though the JSON that came in did change. So in this case, the schema on read and schema on write are not getting us in trouble. Other extensions. Imagine like you got more information on a city than the stinking city name. Wouldn't that be great? So what are you going to have to do there? Well, you're going to have to alter the table and add columns. More details on children. You could add another table off a person specifically for the children subtype. If there were details about the kids that you weren't tracking on other people as well. So you add columns or a dependent table. You could add optional columns in the person table, depending on how normalized or not you want to go. All right, data vault style. Well, okay, hub person. Makes sense. In this case, our magical primary key is the name. And notice one of the things I'll mention about data vault, because it's data warehouse based, there's a lot of metadata columns, which is why these tables look so much bigger. So we have a load date and a record source as mandatory columns in every table in a data vault structure, right? Because we're tracking, it's a data warehouse, we're going to track when the data was loaded. So obviously a JSON document doesn't give us that. That would be part of an ETL process that would gather that information. Let's see, sat person is the attributes that are associated with that person name. So we have the area code, phone number, age, gender, etc., all in the dependent table in a data vault model. So not too different from the third normal form model, except we've actually moved the age and gender down into the dependent table because we're now going to track history. So the primary key there is the key from the person hub plus the load date. So if somebody changes their gender, we're going to capture it here, right? And the model supports that. So when the values come through in your JSON document and they've changed, you now have a way of actually capturing that. Children looks a little different in this case. It's actually a link table in the data vault world because all the foreign keys in data vaults are abstracted into link tables or many-to-many associative entities. So in this case, because we had that recursive relationship there of parents to children in the person table, we end up with a link table that has 2 foreign keys to the person table, a parent foreign key and a child foreign key, right? And we're going to capture all of that. Then we get to city. Again, city is a hub. City lived in the third normal form model was an associative entity, and in data vault, same thing again happens here, that you end up with the associative entity called a link in data vault terms between hub person and hub city. Now this is in data vault, there's a thing called a transaction link, the year actually ends up in there. In Data Vault terminology, normally a link is made up of just relationships to hubs, but it's silly to have a hub just for a year. So this is one of those exceptions in the Data Vault land. We call this a transaction link, and we put the year, that one attribute that actually makes it distinct, actually goes into that table. There's a whole book on this if you're interested in how to go about doing all of this. So now what happens if the schema changes? Well, with the Data Vault model, there's one additional thing we can do. Two parents, same kid. Because the hubs are all independent definitions of persons, and the link object handles many-to-many relationships, you can now handle getting information about two parents with the same child in a JSON document. So you have Johnny Appleseed came through, and then Mrs. Johnny Appleseed came through, and the same information is actually listed in both for the children. You can now handle that with this schema. You would not be able to do that in the third normal form schema I showed you because it was a one-to-many recursive link. So kids get a phone, same issue. That information goes into SAT person. Kids move out, same as the third normal form. It fits just fine. Slightly easier extensions. If you get more details on a city, you could actually add a satellite on that hub city. So if you get additional descriptive information about the city, say like the lat long coordinates, something like that, you would add a satellite in a Data Vault model rather than just adding a column to the table. You just add a whole new table again, allowing you to keep the current structure you have without having to refactor it. You're adding, it's an additive approach to modeling, which is why it lends itself so well to Agile, and finding requirements late in the game is your change to the schema is an add, not an alter. So the thing I wanted to get across to everyone is that, number one, the top thing there, we still need data models and we still need data modelers. So even when we're talking about schema on read, if you want to make use of that data, you have to figure out what it means. Even all the virtualization tools that are out there, so composite software, which was bought recently, this last year by Cisco, and Denodo, which claim to allow you to do virtual data warehousing and building a virtual model, though they don't use the word model, a virtual layer on top of any number of databases and any number of different technologies. In theory, you can go in and connect all of your different disparate databases together using their tool and get one definition for everybody to look at. And that's what they query. Well, it turns out that's actually called a model. And it's a semantic definition. You still have to rationalize it across multiple databases. And the schema on read is the same thing. If we're going to express it in terms that mere mortals can understand and query and do analytics on, we have to have a vocabulary for that. And the vocabulary exists. It's called data modeling. So you just have to figure out how to take it out of those documents and put it into something. So I used Oracle Data Modeler to do it. Now the nice thing with that is once you have that model in the database that has the facilities for natively ingesting things like JSON documents, you can just create a view. And to every reporting tool on the planet, a view looks like a table, right? You expose it in a metadata layer somewhere, and that's the definition. And so now you can have people running reports against JSON documents. And you have obviously options on how you will model it. You can model it third normal form. You can model it as star schema. I just didn't do that because I figured 2 modeling techniques was enough for one talk. I didn't want to explain dimensions and facts as well as hubs, links, and sats and intersection entities all in one talk. But you can model it any way you want. You can model it denormalized, as I showed you in the very first example. You can flatten it all out. You know, if you've got data scientists who are trying to do things with JSON documents, you could create a flat view on top of it. many, many options that you can do. So we have to be able to understand the schemas. We have to be able to express the schemas. So when anybody says, hey, schema on read, piece of cake, we're off to the races, ask them, so do you ever intend to query that data? What's your plan? What tools do you have to query that semi-structured data? So people are still talking about data lakes. I'm sure you're all hearing about it in your organizations. And the question asked is, what are you going to do with that data lake? Once you put that data in, what's your intentions other than storage? If it's just file backup, okay, don't call it a data lake. Call it a file backup system, right? If you want to query it, though, you want to use the data, whether it's for machine learning, data science, or just plain old, boring operational BI, and it is JSON type documents or XML or Parquet or ORC or one of those other semi-structured things, how do you intend to get it out? You've got to get people to think about this, because many people are going into these, and we see customers like this all the time now, that they've been sold by one of the vendors. You got to have a data lake. They've stopped saying Hadoop. They're not saying it has to be in Hadoop anymore, but you can use S3 on Amazon, right? You dump all your data into S3 blob storage, and that's your data lake. Well, what do you intend to do with it afterwards? How are you going to access it? And make sure folks are thinking about that, because it's not just loading the data. There may be other technologies they need. And if it's somewhat structured like this with JSON, you have options to put it in a relational database to make it easier for people to access. But to do that, you are going to have to put a schema on it. You're going to have to take that schema out of the schema on read and turn it into something that looks like, at least, schema on write in the traditional sense. So you can do, as I said, many different ways. You have lots of options to modeling it, whether it's third normal form, data vault style, star, object model. You could use UML. You could do an object model on these things too. Your choice. The main thing, though, is you need to think about it, and you need to plan it, and you got to plan cycles in the project to do it. You have to figure out, how are you going to build effectively a semantic layer on top of your semi-structured data so that the business can understand it. One shameless plug, I do have a book, Tips for Enhancing Your Use of Oracle SQL Developer Data Modeler, that has a little bit of this stuff in it. It's out on Amazon. If you're interested, if I got you curious about Data Vault, I also have a book on that, Introduction to Agile Data Engineering using Data Vault 2.0. Both available on Amazon. If you just go to Amazon, search on my name, you'll find it. If you go to my blog site, kentgraziano.com, you can find links to the books right there on the right side of the page. And if you are interested in trying out data warehousing as a service in the cloud for free, we have that available. You go to snowflake.com or snowflake.net, either one works. And there's a little there's buttons all over the place. You cannot miss it. Where it says try for free. Every single page it shows up on. So we have a really good web designer that figured out how to make that, what we used to call it, modal, right? No matter what page you're on, that button shows up. So feel free to go out there. And as I said, if you have questions about any of this, Danny, Michael, and I are going to be here for most of the day, unless, are you guys presenting at OOW anywhere today? Nope. Okay. So they're going to be here today. Feel free to talk to us, grab some stickers out front. My contact information, should anyone want to get a hold of me, I'm easily found on social media, on Twitter. Feel free to reach out at any time.